This is definitely the craziest project I worked on at Monday.com. I was asked to build a Japanese dancing rat theater. A lot of code, LEDs, smoke, sound. There was so much work put into this project that we had to break this video into 3 different parts. Today we're going to talk about how to build robotic rats from scratch and eventually make them dance. So here's another video from the Monday makers. Ratsy, push the button. So we bought a bunch of these rats. They're just standard IKEA rats. We have to build a skeleton. We can have their hands move, we'll have their head move, make them maybe also kind of pan and bow down. So we're gonna build a skeleton out of wood, and we'll have servos inside. Then we'll figure out how to sync them all to dance together to the music and have the LEDs sync up with all of that. So let's get to it. Okay, take some measurements here of the body, and so we can figure out what size skeleton we want to do. It might take a few iterations until we have the skeleton right. That's why I want to use a laser cutter so I can do quick iterations. 3D printing will just take too long. So we're going to use 2 types of servos here, I think. We're going to do maybe 2 larger servos for the base, for the pan, and for the tilt. And then maybe smaller servos for the head and the hands. So I'm thinking to use some relatively heavy-duty servos. The cheaper servos are typically nylon, about $1 a piece. These are the SG, they're the nylon servos. But instead of these guys, I want to use the Metal Gear servos, the MG, because I want to know that these will work for a while. Metal Gear just means that they have gears inside that are made out of metal, and it'll last longer and it'll be a little bit more accurate. Maybe a little bit more quicker in response. All servos that we're using can only do 180 degrees turn, and that's good for our needs. And we're probably gonna limit the limbs, only do like 15 or 30 degrees, we'll see how much, so they don't break into each other or kind of like do an awkward motion backwards. Take some measurements, okay, and also the small servo. All right, excellent. All these servos run on about 5 volts, I think 3.3 to 6 volts-ish. We're gonna use 5 volts for this whole project. So we're gonna go ahead and go to Illustrator now that I have all the measurements. I'm going to create some sort of shape that will be able to hold the servos inside. We have 20 millimeters here, so we'll just use 2 10-millimeter pieces of poplar wood. I think for the limbs, we'll use 4 millimeter. So it'll be a little more thin. Make some holes for screws. Measure the distance between the screws. All right, so we have our first version of the skeleton. Let's take this over to the laser cutter and cut it out and see if it all fits together. All right, cool. These will be little mice hands and a little mouse head. All right, so let's see if it all fits. So I'm thinking that we'll have this servo facing down, and we'll have it connect in from here. So I did some engraving to cut away 1/3 of the thickness of each side of the poplar wood so that we don't have to drill a hole manually because I'm lazy. This servo that will fit there. So we're gonna have the pan, and this will give us the tilt. All right, let's connect this all together. Screw this part to a base we'll make for all the rats. Let's screw in the servo. Important to remember to do pilot drill holes before touring in the screws because otherwise the wood cracks like this. This part does the tilt. We have the 2 hands, and we have room for a 3rd servo on top. This will be the part that holds the head, and we made also this little part connected there, and this will all connect. Professionals say that you should use a manual screwdriver when you connect fine screwing like this, but I'm too lazy. Always use electric. The rat is looking at its new body. All right, so we made 3 more. We have now 4 mice. We'll have to fit in the actual mice next. We're gonna have to wire them all up, put on the mice, and connect them all to a microcontroller and add some code to that, and then see them actually move around. It's time to cut this baby open. Hope it's not gonna hurt too much. We're using a surgeon's knife. Sorry. All right, let's make some room for the skeleton. Make it a robo mouse. See if it fits. Okay, I have a new body. It needs some fine tuning, but we're close. Who's my good rat? We're gonna add a kimono. Maybe we'll have somebody come in and help us sew a kimono, a little mini kimono for the rats to look even more Japanese. This is probably one of the more complex projects that I had recently because we have a lot of things that have to kind of like work together. I think the whole communication between the mice is like a big challenge. First of all, we want the servos not to fail. If something stops working, it has to be something that we can replace quite easily. The lights have to look good. The sound has to be kind of like nice and all in sync. There's a challenge here of syncing it all together and making it look nice. I mean, to make something functional, that's typically easy, but to make it like artistically nice, that's the bigger challenge. We're gonna now solder female headers to a prototype board so we can have a little nice seat for the ESP to sit inside. If this lab burns down and I can save one tool from this lab, it will be this, my favorite tool. This wire stripper, also pretty inexpensive, easily cuts any gauge of wire perfectly, takes off the insulation to the length you'd like, and exposes the wires that I need. Oh yeah, oh yeah, oh perfection. All right, so we have the 5 3-wire cables that run to each one of the servos. And I soldered an extra cable for direct power from power source that's not the master. We want to get an external power source so we have enough juice to give it the current that it needs. The servos can drive quite a bit of current. So for some reason, I keep burning out these servo motors. I burned out probably at least 10 until now. I'm not totally sure why it's happening. I've been consulting with folks on Facebook and different forums. I took one of the motors apart to kind of look for clues to find out what's going on. And it seems that the plastic enclosure is deformed due to excessive heat coming out from both the motor and the little integrated circuit that's the brain of this motor. Maybe it's just a really poor quality of servo motor and I have to pay a little bit more than $1. And maybe they're trying to kind of push the cloth and because of the weight, it's just constantly fighting it and then eventually just burns out. That might be the reason, so I might have to give the cloth more slack. We'll see, I'm not sure. We'll have to try different things and hopefully we'll figure it out. So despite these problems, as the rats always say, the show must go on. All right, so now we have our 5 rotary encoders, which we need to make a little box for and solder them together. I'm gonna solder all the grounds together and all of the voltage pluses together. So we have less cables running to the microcontroller. And then we'll take one cable out from one of the grounds and one of the pluses to our microcontroller. All right, so we have our rotary encoders all wired one to the other with their grounds and their voltage plus. I made this quick little box off MakerCase online. I got the plans for MakerCase and I cut the little box in a laser. And I will finish connecting the rotary encoders to our little fancy box. Get some caps on and let's glue this box shut. All right, so this past year I discovered this stuff. We call it the death spray because it smells like death. It's an instant adhesive surface activator. You just spray the stuff on the glue after like a second. Instant solid. Okay, we're all hooked up. Let's see if it works. And it's alive. All right. So I came back from GeekCon last week where I discovered this cute little part, which can actually simplify the whole architecture of this project. This part essentially lets you connect 18 servos and you can just send serial data to it from the ESP32 or Arduino or any controller you have, and then control all those 18 servos. So that lets us only use one controller instead of using a controller per rat. So it'll really simplify everything, and hopefully the servos will also react a little bit better because right now it has some communication problems with the servos. So we're going to try to use 2 of these and 1 controller instead of what we did until now. All right, so we have 5 rats set up. They're all assembled here. They're connected to servo controllers that are hooked up to the ESP32 that will control them. Now we have to make some kind of a gamepad control box where we can make the rats dance and choose which rat is going to dance at what part. And while we're at it, we'll already throw in extra features where we can record sequences of moves and then play them back during the dance curation. So let's make that controller. So now we have our Q controller over here. Now we just have to throw some code on the ESP32 to make it work. So let's get to it. So the controller is all coded and ready to go. It now can control each rat. You can choose which rat will dance in every given part. I added a few features into it where you can build sequences of moves, which you can then play back, or even trigger the smoke, the laser show, the LED theme. But we'll make a separate video about special effects down the road. Join me in the next video where I show you how I built this pagoda, which has been inspired by the traditional Japanese no theater pagodas. All done handmade, besides one little part. And there are a lot of first time things for me. So it's been quite a journey for me, a lot of fun. Don't forget to subscribe, like, and I'll see you in the next video.